Today, we're going to be using OpenTelemetry to implement distributed tracing across a simple collection of example microservices. OpenTelemetry is a collection of tools and a standard way of handling telemetry reporting that will help us make sense of a user flow that spans multiple microservices, as well as having asynchronous components such as a message queue involved in the process. We'll go through how to set up auto-instrumentation across services, as well as how to read the traces to make sure that we have basic visibility into our user flow. For this demo, we'll be using a sample set of microservices, as well as some supporting infrastructure. First, we'll go over the elements involved. Then, we'll describe the user flow that we'll be tracing, before getting started writing the actual code to instrument these services. In our demo architecture, we've got NGINX acting as a load balancer and reverse proxy, as well as two microservices, one called Messenger, which is a chat application, and one called Notifier, which is tasked with dispatching notifications from the system to users. Both services are written in Node.js, and they depend on their own Postgres database. Additionally, we've got RabbitMQ in the system acting as a message broker. In our user flow, we're going to be tracking a user sending a new message to another user. That user will send a request, which will be routed through the NGINX reverse proxy and be handled by the Messenger service. The Messenger service will write the content of the message to the Messenger DB, and then dispatch an event over the RabbitMQ queue, indicating that a new message has been sent. It'll then send a success response back to the original message sender. At the same time, the notifier, which is listening on that same queue, is going to consume the event about the new message. It'll determine who the recipient is and go into its database and retrieve that recipient's notification preferences. It'll then send any notifications via the methods that that user preferred. So for example, if the user asks to be notified of new messages via SMS as well as email, they'll get two notifications even though only one message was sent. Now that we understand the flow, let's use OpenTelemetry's tooling to set up a distributed trace for this flow. We'll go through the following process for this. First, we'll set up basic tooling and make sure that it's working. Second, we'll think about what kind of insights we want to get from this tracing that we're going to set up. And third, we'll evaluate and modify the traces to help us get the best insight into this user flow. So let's start by setting up the tooling. For that, we'll jump over to the code where I've already prepared the basic boilerplate. Now, the most complicated part about this code is all of the libraries that we're importing and how we're using them. So here are all the imports, and if we take a look at the dependencies that this application has in terms of what's being provided on the OpenTelemetry side, we'll see that there's quite a few. We have API, which is the general interface into all of the pieces of the OpenTelemetry library, and we'll be using a lot of this directly. We've got auto-instrumentation for Node, which is just a collection of all the various instrumentations so that we can just set up one instrumentation configuration, get kind of everything for free. We have an exporter for OpenTelemetry that specializes in exporting the traces generated by OpenTelemetry in the OpenTelemetry format. And we've got other libraries such as resources, which defines the entity that's sending the traces. We've got the core SDK, which actually generates the traces. And we've got the semantic conventions, which define all of the legal fields that can exist on a trace or a span that's sent. So this is a lot of libraries. And you might wonder, why are there so many libraries? I don't know for sure, but my best guesses are that it's partially to do with maintenance. So if we look at the set of libraries provided by OpenTelemetry, it's actually quite large. And there are more than are actually listed here, as we'll see later in this demo. But they're all in varying degrees of development, and the spec itself is also evolving. So when we have something that's evolving like this and you have such a large maintenance burden, perhaps there's a benefit to splitting up the libraries in a certain way so that you can get some of those pieces that change and need to be updated across the whole stable of libraries through with less work. The other reason is that when you're doing instrumentation, especially in performance-sensitive environments, you want to have as little instrumentation code as possible. So going back to the dependencies that we have here, we could, for example, if we included all the possible exporter formats that could exist, then we'd be bundling a lot of code in there that doesn't need to be used. Same goes for some of the things like the semantic conventions. If you didn't need to tag things, then I guess you could save some code imported into your final bundle by not using that. That being said, let's take a look at the code. So the first thing that we're going to do is we are going to set up some basic logging, which for our purposes isn't going to be too helpful, but we'll see it flashing by. Next, we're going to create a resource. This represents the entity that is dispatching the traces. So in this case, the resource is our messenger application. And here you can see that we're using the semantic resource attributes object from the semantic conventions package to make sure that we're getting the service name tag exactly right. Next, we're going to take that resource and pass it to a new instance of the Node SDK, and we're going to configure the trace exporter, i.e. the format that we're going to export the traces in, to be the OTLP exporter, which is the OpenTelemetry format. Finally, we're going to add all of the Node auto instrumentations as the instrumentations, and we're going to start up the SDK. So that's all we need to set up, and it's in one file outside of our application code. So I've already got that running, and I've also got similar code set up for the notifier. So if we go into tracing, we'll see that we have very similar code set up here in the notifier application as well. I've also got code set up for the NGINX load balancer. Now this is a little bit different. We're actually installing a NGINX dynamic module that is also provided by OpenTelemetry. You can see here. This is a file that is compiled, and then we just put it in the correct directory, and then we inject some code that loads that module in the NGINX configuration. In this very simple NGINX reverse proxy configuration, we're also loading up configuration for the NGINX OpenTelemetry module, which is pretty simple. The things to pay attention to are that we're setting the service name here, and we're telling it to export in OTLP format. So with all that set up, we can actually send some requests to our fake messaging application and see what kind of traces we get out the other side. Now this application is fully text-based, so unfortunately we won't have a UI example here, but we'll see the message go through and we'll see what we wound up sending. And then we will jump over to the Jaeger UI, and Jaeger is a tool that allows us to view traces as well as acting as a collector for OpenTelemetry. It's kind of an all-in-one solution. And we can click Find Traces with the Messenger LB as the start service, and we can see our requests come through. So we've got the NGINX load balancer here, we've got the Messenger microservice here, and the notifier microservice here. So all three of the pieces of our system are being traced, and those traces are all connected, which is great. We have a distributed trace. So before we move on, let's take a moment to think about what we want to know from these traces. It's usually better to think about beforehand the information you need instead of looking at the traces and trying to kind of guess based on those traces what might be nice to know. So let's think about it for a moment. First, we want to understand all of the steps in the flow here that we're trying to trace, which is the new message send flow. So we want to know that it hits the NGINX load balancer. We want to know that it hits the messenger service. It goes to the database. It goes across the RabbitMQ message broker. It gets eaten by notifier, which looks at its database, which in turn sends a notification. So very simple. We want to verify that flow. Secondly, we have a non-technical consideration and more of a user experience or a product consideration, which is we just want to know that this is going to complete within 5 seconds. We want to be able to tell users any message that you send is guaranteed to wind up showing up in the system within 5 seconds. And finally, we want to know that the notifier service received the event dispatched by messenger in a reasonable amount of time. So if we look at it here on the diagram, that's this part. So the messenger sends the dispatch the event, and notifier consumes it. Now, if notifier takes a long time to consume it, we can maybe assume that maybe it's backed up. Maybe there's a lot of messages that it's trying to chew through, and that would be something we'd have to jump in and remediate. So those are the 3 questions that we want to answer. And what we're going to do is go through our trace and one by one look at the portions of the trace and evaluate whether these answer our questions. So here's the NGINX portion of the trace, and we're just going to go through top to bottom. So the first thing we want to know is, does this help us understand all of the pieces of the request? So just by the fact that we have the Messenger LB or the NGINX reverse proxy service here in our trace, that tells us one thing, but let's dig into the tags. So the first thing we'll notice is that the target says conversation 1 messages, which is the correct endpoint for the flow that we're trying to trace. But it doesn't guarantee that this is a creation of a message. This might be someone reading the message. To understand that this is a creation, we need to look at the HTTP method, which is post. So that verifies that this is in fact a message send. Finally, we'll look at the HTTP status code, which shows a 201 created status, which further sort of cements that we did indeed create a message. So that does check off that first thing that we want to know. The second thing is this complete in 5 seconds? So looking at the NGINX load balancer portion of the request, we can see there's a number of spans, but if we look at the last span, we see it starts at 398 microseconds and takes 16 microseconds. So it's around 400 microseconds in the NGINX portion of the request. So this doesn't take us anywhere near that 5-second mark, but we still need to keep going and know more before we know that we've definitely gone under that mark. And the last question involving the notifier we won't tackle till we get down to the notifier portion of the trace. Next, we'll move on to the messenger service portion of the trace. And again, we'll look at the parent span here. And going back and thinking about our first question, can we identify all the parts? We can look at the tags again and see, okay, we're hitting that route, which is nicely sort of genericized. So we've got conversations and the ID of the conversation and messages. Same as before, we don't know whether this is a message creation or a fetch, but we can look up an HTTP method to see that it's a post, and the status text of created to show us that we actually created the message. So this again verifies. Now if we go back to our diagram here, we can see we've hit this part and we've hit this part. So those two are so far doing a good job answering that first question. Now let's do what we did before and go down to the last bit of the messenger trace here and see that it starts at 41 milliseconds and took 228 microseconds. So we're looking at around 42 milliseconds here. We're still well clear of 5 seconds. However, as I said before, we're not at the end and we can't be sure that we haven't hit 5 seconds until we hit the end. So let's keep moving. Looking at the notifier trace, we will see an answer to the last question, but let's hit the first question first. So here we hit notifier. We know that we hit notifier because we see a chat queue process. And if we look at the tags, we can verify that this is indeed the AMQP, and AMQP is another way of referring to RabbitMQ. You can see that under messaging system here as well. And we can see that is a process operation. Right above, we saw a chat queue send operation. Where's the operation here? Messaging destination. I guess it's in the title of the span here. We can see that there's a send and a processing of the message. So that kind of tells us that we hit all of the pieces. So NGINX to messenger. You can see that there's some database access going on here, and PG pool connect, TCP connect here. This is where we are at least connecting to the database in the messenger side of things. And then here in the notifier, we see down below, there's also this database stuff. And we'll talk a little bit more about that in a moment. But we can see that we are hitting all the pieces here. We see AMQP or RabbitMQ. We see database access in both services, and we see both services spans show up in our trace. So that tells us that we hit all of the pieces. However, I don't see this last piece. I don't see notifications being represented in the spans. I just see this database access and then nothing. So that tells us that we're not in a position where we can answer that first question. We don't know what all the pieces of the user flow are and how long they take. We also can't answer the second question because the second question depends on having all of the pieces there top to bottom. If sending the notification takes 10 seconds, we are not satisfying that user experience requirement. But we can validate the last question, which if we go back and review our questions, is did it take a long time for the notifier service to receive the event dispatched by messenger? And here we can see the event being dispatched by messenger, chat queue send from the messenger service. And that happens at 41 milliseconds and takes, so about 42 milliseconds. And then we can see chat queue process happening here, and that's happening at around 43 milliseconds. So there we have a nice clear answer to that last question, which is, at least in this case, it did not take us a long time to consume that message. So what are we missing? We're missing information about the notification send. So let's add some custom spans to our application to make sure that we have those ready to go. And I will add some code for that in the notification, the notifier project. So here's the notifier project. And for this, we're actually going to go into the application code. So I'm in the main file of that project, and I've got the import from OpenTelemetry API. And then what I'm going to do is I'm going to head down to the end where we actually sort of fake sending the message. So here's where we've got the user's notification preferences and we're iterating over them. And this is all we do to show a notification send. So what I'm going to do is I'm going to modify that code to, and it's going to be a lot of code that comes in, but I'll go through it step by step so that we understand. Here we go. So here on line 91, we're going to get the tracer, and this is going to be how we're going to start sending spans. And then we're going to start a span, and this is going to be a parent span, and we'll give it a name, notification send all, and we will give it a user ID that is the user ID of the user that sent the message. And then inside that span, we're going to start another span. And for each preference that the recipient user has, we're going to send a notification.send span with attributes that detail the type of notification. So this might be email or SMS, and the user ID of the user who is receiving that notification. And then we'll actually go down here and do the work, and then we close up those spans at the end, and it actually sends them. So we've got a kind of nested custom span going on here. So let's go back to the command line. I will stop the notification service, and I will start it back up again. And then I'm going to go ahead and resend the same message, and we'll take a look at how that looks in the distributed trace. So send that message again. It was successful. And then we'll jump back to the Jaeger UI and redo our search. And sometimes you'll see in the UI, it takes a moment for the full trace to come through right after you send it. So we click send again, and we'll see that those notifier traces showed up. And this should all look familiar. We don't expect anything to change in the NGINX portion, nor in the messenger portion, but we expect things to change in the notifier portion. And we see that notification send all that we made. If we click on that, you can see that the user ID is 2. That was the user that sent the message. And then we are going to look at the individual send events. And actually, let's take a look at what feedback the notifier gave us when we sent that message. And it said it received a new message and it sent a notification via email to this email address. And it also dispatched a notification via SMS or text message to that phone number. So we can look here and see that indeed we got a notification send of type email, notification type email, and we got a notification send of notification type SMS. So going back to our diagram, we see that we are now got to the end of all the things that we want to verify. So that checks off our first question. We now know all the steps that the request takes. Also, we can take a look at the last timestamp and see that it was at 119 milliseconds and took 76 microseconds. So we're definitely still well under that 5-second mark. So we can check that one off as well. And we checked off the notifier portion of it earlier. So that's about it. We have successfully auto-instrumented 2 services and gotten information about the reverse proxy load balancer, as well as the pieces of the system that these services are interacting with, such as the database and the message queue. And we have taken this approach of defining what we want and then making the traces fit what we need to find out, and that required sending some custom traces that weren't provided to us automatically by OpenTelemetry. So what's next? We've barely scratched the surface of this. In reality, when you're setting this up, you really want to spend a lot of time getting this just right and making sure that you're not sending too much. So the things that we didn't do here that might be the next steps, might be to take a look at some of these spans that we're getting and think about, do we really need these? Do we really need to understand that it took 62 milliseconds to initialize Express in Node.js? Also, we can take a look at some of these database things and maybe go and send some custom spans to time exactly which queries are happening and how long they're taking, so we can keep an eye on that. So kind of the sky's the limit. It really depends on what your team needs to know to make sure that it's meeting its technical and its user experience objectives. Thanks for sticking with me on this, and I hope you enjoyed it. Thank you.